Okay, 2.4, we talked about finding the zeros of polynomials when we are given one. Then we use synthetic division to take it out, and then we usually get something that is nicer to deal with. Well, 2.5, we talk about what to do if we didn't have anything given to us at all. So we use what's called the rational zero theorem. So what this does is it gives us a list of possible rational zeros. Doesn't mean that all of them are actually going to be zeros, but it's if there's a rational zero, it will be at least one of these. So on your paper, you don't have to write this again because it's already in there, but because I don't have anything printed out here where I'm at, I'm going to rewrite here just for your benefit in watching the video. So the possible zeros, you're going to take the factors of your constant, which is the number at the very end that doesn't have the x, and you're going to divide those by the factors of your leading coefficient. Remember that leading coefficient is the coefficient to the variable that has the highest degree. And then it's going to be the positive or negative that. And I don't think this positive or negative is in your notes, so just make sure that you know that it could be the positive or negative of those constants. Because, right, if, let's say, you have 1 times 3 is 3, but negative 1 times negative 3 is also 3. So the positive and negative are both factors of that number. So if you look at the first example, so in 1a, our constant in this case is negative 3, and then our leading coefficient is a 4. So if we want the factors of my 3 or negative 3, we have a 1 and a 3. The factors of my leading coefficient are 1, 2, and 4. So 1 times 4 or 2 times 2. Which means your possible zeros, everything of each one of these over each one of these. So we have 1 over 1, 1 over 2, 1 over 4, 3 over 1, 3 over 2, 3 over 4, and that's it. So those are all of our possible zeros. Possible rational zeros, sorry. I mean, there could be some irrational or some complex zeros, but again, if there was rational ones, it would be one of these. And of course, we can then simplify each of these. So 1 over 1 is 1. We have 1 half, 1 fourth, 3 halves, or 3 fourths. Okay, 1b. My new constant here is 6, and my leading coefficient, is a 3. So the possible rational zeros are all the factors of my constant. So factors of 6, 1, 2, 3, and 6. Factors of 3 are 1 and 3. So if we take, this time I'm going to take all of these over this one and then all of these over this one. So possible, you have 1 over 1, 2 over 1, 3 over 1, 6 over 1. Or you have 1 over 3, 2 over 3, 3 over 3, or 6 over 3. Note though that this equals 1, 6 over 3 is 2, which are already stated here. So these are repeats. So you have 6 different possible rational zeros here. Okay, objective 2. Now we're going to use this theorem to help us find zeros. So for 2a, we have f of x equals x cubed plus 2x squared minus 5x minus 6. And I'm sorry, in your notes, the lines are kind of off. I didn't have enough time to fix the formatting on this one. It was just kind of way out of whack. So in this case, so if we think about the degree, so this is 2a. So the degree of this one is 3, which means there are going to be 3 zeros. So if we want to find all 3 zeros, we need to have somewhere to start, because if we look at this one, if we wanted to try to factor by grouping, it just doesn't. So we do have to do something. So if we want to look at the possible zeros, possible rational zeros, so we're going to take the factors of the constant. So in this case, it's the factors of 6. We're going to divide each of those by the factors of 1 in this case, because the leading coefficient is 1. So factors of 6, 1, 2, 3, and 6. Factors of 1 are just 1, so we have the positive and negative values of 1, 2, and 3, and 6 as our possible rational zeros. So what we're going to do with this is we're going to just start testing them to see if any of these are actually factors of my polynomial. And of course, if they are a factor, then when I divide by the x minus this number, then my remainder is going to be 0. So I just started taking them one by one. So I usually start with the ones because they are the easiest. So if I want to see if x minus 1 is a factor, so that 1 is a 0, then synthetic division, I'm going to bring down all my coefficients. So I have a 1, a 2, a -5, and a -6. My 1 comes down, 1 times 1 is 1, 2 plus 1 is 3, 3 times 1 is 3, 3 minus 5 is -2, -2 times 1, so -6 minus 2 is -8. So this is not 0, so 1 is not a 0. Well, let's try -1. So my coefficients are the same. Bring down the 1. 1 times -1 is a -1. 2 minus 1 is 1. Again, 1 times -1 is -1. -5 minus 1 is -6. -6 times -1 is a +6. -6 plus 6 is 0. So 1 is a 0 of this polynomial. Well, now my new polynomial is, I started with x cubed, so now this is x squared plus x minus 6. So at this point, I have a quadratic, and then I can use any of my methods that we've learned to solve for this. Now in this case, we need, if you want to look and see if it just factors nicely, we need two numbers that multiply to 6 and are going to subtract to 1. In this case, that is 3 and 2. So this is going to factor, we want a +3 minus 2. So x plus 3 times x minus 2, which means my other zeros, we have a -3 from here, we have a +2, and then the -1 that we found before. So my 3 zeros of this f of x is going to be -3, a +2, and a -1. Okay, and I just realized another typo. We have another 2a. Well, let's call this one 2b. And I need another page. Okay, so if we call this one 2b, our second 2a, again, we have a degree 3, which means there are 3 zeros. To get the zeros, I want my factors of my constant. And my constant in this case is 3 over the factors of my leading coefficient, which in this case is 1, which makes it easy. So my possible rational factors are just the factors of 3, which is 1 and 3. Okay, so if we test +1, and you can test these in any order you want. I tend to start with the lower number and work my way up, but that's just me. So bringing down my coefficients, I have a 1 and a 7 and an 11 and a -3. Bring down the 1. 1 times 1 is 1. 7 plus 1 is 8. 8 times 1 is 8. 11 plus 8 is 19. 19 times 1 is 19. 19 minus 3 is 16. So 1, again, is not a factor. So let's try a -1. 1, 7, 11, 1 times negative 1 is negative 1. 7 minus 1 is 6. 6 times negative 1 is negative 6. 11 minus 6 is 5. 5 times negative 1 is a negative 5. And this is negative 8. So again, negative 1 is also not a 0. So I have 2 more to check. Let's check a positive 3. So 1, 7, 11, and negative 3. Now this one, you may notice right away that we have 3 positive numbers here, and this is always positive. So this is going to end up giving us a really large positive number, so it's probably not going to be 0. But we can double check anyway. So we have 30, 41, and it's 123. So this is really not. So if there's something like that, you can see you don't actually have to see all the math. You can just say, okay, I know that's not going to be it. So we are going to want a negative. Well, let's hope that this one is, so 1 times negative 3, 7 minus 3 is 4, 4 times negative 3 is negative 12, so we get negative 1, negative 3 times negative 1 is a positive 3, and this comes to 0. So our last one we checked, negative 3, is in fact a 0, and the polynomial we get at the end is an x squared plus 4x minus 1. So now we can try to factor. In this case, we would need 2 numbers to multiply to 1 and add to 4, which does not work, which means we are going to have to use the quadratic formula because we are solving for zeros. So we want to know when this equals 0. So if we use quadratic formula, we have a negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Okay, so we have a negative 4 plus or minus square root of 16. Negative 4 times 1 times negative 1 is going to be a positive 4 over 2. So negative 4 plus or minus the square root of 20 over 2. Now 20 is a 4 times 5. So the 4 can be taken out. So we have a negative 4 plus or minus 2 square root 5 over 2. So now we can divide both terms by 2, and we end up getting a negative 2 plus or minus square root of 5. So our zeros here, we have the negative 3 that we found before, which is the only rational 0, and we have the 2 irrational, negative 2 plus or minus the square root of 5.